Welcome. We're going to solve some polynomials. And what we're going to do is first look at the fundamental theorem, which says that as long as the degree is greater than 0, then at least one root is a complex number. Complex numbers are the a plus bi type. And all of our normal numbers, say, let's just take the integer 17. That's actually 17 plus 0i. We don't see the I because the coefficient is 0. And if we have a complex or a normal imaginary number, like let's say negative 5i, that's actually 0 take away 5i, because there's a plus bi and b is minus 5. So they're all complex numbers then, which means that the solutions are going to be complex either because they're going to be a regular number like that with 0i, or they're actually going to be imaginary numbers. Well, let's go ahead and solve a few. We need to state the number and the types of roots. Well, we can do that in a number of ways, but I have found that the easiest way is just go ahead and solve it. So when I look at this, I see that there's a coefficient I can take out, and that's x squared minus 3x minus 10, and that equals 0. So now they each get their separate zeros. X is equal to 0, and x squared minus 3x minus 10 equals 0. So we actually have one of the solutions here. And we have two more to find. We can always use the quadratic formula if it's an x squared. However, if it's factorable, that will be faster. And this one is factorable. This one, it looks like, is x. Let's see, to get a minus 3, we need minus 5, but they need plus 2. So negative 5 times 2 is the negative 10. And then when we get the middle term, we get negative 5x plus 2x. That looks good. They each get their separate zeros. And so that means we have x is equal to 0. Here we get a 5 on this side because we'll add them and we'll subtract 2. We have a 0, a 5, and a negative 2. So that is our set. Actually, I like to write them when it's possible as a set, solution set with the in order numerically from smallest to largest. Now, that's the solution, but we want the number. So there's 3 solutions. And actually, I'll just say 3 real solutions, and that tells us the type. 3 real solutions. And such is our answer. We have solved it, and we have stated the number and the type of solutions. Now let's do another one that shows a different factoring technique. This one is well, let's take the x out, and we see x squared minus 36 is equal to 0. So you have x equals 0, and we have x squared minus 36 is equal to 0. And this one is a difference of 2 squares, x minus 6 and x plus 6 equals 0. So they each get their separate 0. So we get a 0. This one will be a positive 6, and that will be a minus 6. Or I'll do it the long way here. So x minus 6 equals 0, x plus 6 equals 0. So add 6 to both sides. Over here, we subtract 6 to both sides. So we have negative 6, 0, and 6. And that's 3 real solutions. Again, just different solutions. Okay. Now, this next one is very similar, but with a twist. I like this twist. Of course I do. I made it. Okay, but let's see what happens. We get x equals 0, and we get x squared plus 36 is equal to 0. Oh, but this one is not factorable in the normal way because it's not a difference of 2 squares. It's a sum of 2 squares. And that we can't factor by just splitting up into 2 separate little binomials. Here, what we're going to do is we're going to subtract 36 from both sides. And then we'll take the square root of both sides. So the square root of x squared plus or minus the square root of negative 36. And so that is x is equal to, well, we have some things to work out here. So let's take a look at this. And for that, we're going to come up here. the square root of negative 36 is equal to the square root of negative 1 times 36, which is the square root of negative 1 times the square root of 36. Square root of negative 1 is I, and the square root of 36 is 6, but it's plus or minus. So that means x is equal to plus or minus 6i. So we have for our solution set is 0 and plus or minus 6i. Usually the imaginary numbers go after the real numbers when we do a solution set. So this is 3 solutions. 1 is real, that's the 0, and 2 are complex. Okay. Which is also, we can just simply say it's acceptable to say imaginary. So 3 solutions of the types being 1 real and 2 complex. So this part about when it's plus 36 plus a perfect square, that's when you do the plus or minus and when you end up with an I. Okay, so notice that progression of how a number can be broken up and the parts taken out if there is anything left over. Now let's look at this on a larger scale. Oh, we have an x cubed with a bunch of things, and this one can't be factored by grouping either. So we are going to use something from the section that's after this. I'm going to introduce it to you now because it's very useful. Look at the last number and the first number, the coefficient. The coefficient at the beginning is called Q. The number at the end, the constant, is P. So this P and Q technique, what it does is it helps us find possible, a set of possible solutions, circle them as positive 9, from which we can choose from. Because right now, where do we even start? We don't have a starting number being told that, say, 2 is one of the possible answers. We don't know. So what we're going to do is to find a set. Instead of all the billions of numbers that are available, we're going to get a smaller set, and this technique helps us do it. So what we do is we find the factors of P, and we divide them all by the factors of Q. Let me write that neater and say that again. Make that right bigger here. Factors of P, and divide them by the factors of Q. For P, it's 9, and for Q, it's 1. So the factors of 9 are plus or minus 1, plus or minus 3, plus or minus 9. In the bottom, we have plus or minus 1. So what that means is we have to make now a solution set of combinations. Let's pretend that this was not a 1 but a 4. We would also have plus or minus 2 and plus or minus 4. So we would have 1 over 1 and negative 1 over negative 1 or negative 1 over positive 1. But we'd also have 1 over 2. And so it would be plus or minus 1/2. And we'd have 1 over 4. And we'd have 3 over 2 and 3 over 4 and 9 over 2 and 9 over 4. Ooh, that's a lot. So it's definitely actually better to have 1 on the bottom. Nice and easy 1. So 1 over 1, 3 over 1, 9 over 1, and any of the negatives. So that means it's really just P's. Plus or minus 1, plus or minus 3, plus or minus 9. That's the set of those 6 numbers. One of them will be one of the zeros. Okay, so that's step 1 that we do here. Step 1 is get that set. Now for step 2, we're going to do synthetic division. With any one of those numbers, I suggest to pick from the easiest ones to use first. And that means now we need these coefficients, the 1, the negative 3, the 5, and the 9. 1, negative 3, 5, and 9. And let's see if 1 is one of the 3 solutions. 1 times 1 Add that up for -2. 1 times -2 is -2. 5 take away 2 is 3. Oh, that means that's 9, 10, 11, 12. Nope, 1 is not a good solution. Let's take -1. 1, -3, 5, and 9. 1, -1, that's -4, that's a +4. Ooh, -9, and when I add it, I get a 0. This is a good solution. Okay, so now I know I have one of them, but I need to find the other two because this tells us that there are 3 solutions. So we already know there's 3 of them. We just need to know how many of each type of solution. And we now know that -1 is one of the solutions. So what we do is we make the depressed polynomial, x squared minus 4x plus 9. That is because we go one less exponent from the original. So this becomes x squared, and we have the 1 in front, 1x squared minus 4x plus 9. So now what we need to do is solve this one. Oh, except that can't be factored. If I try this, it can't be done. So that means we have to use the quadratic formula. X equals -b, which is -4, plus or minus square root of b squared, -4 squared, minus 4 times a times c. All of that divided by 2 times a. So what I did here is I recognized that a is 1, b is -4, and c is 9. A, B, and C. And so I put B in there, and A in these 2 spots, and C in that spot. So make sure you know the quadratic formula, because sometimes you're going to have to use it. Well, now let's actually start calculating this out. That's a +4 now, the 2 negatives. Here we get 16, because -4 times -4, the negative cancels out. And I get -36. Let's go back. -36, and all of that over 2. So let's take a look at this part. Okay. So I have to figure out how to handle that. Well, that is the square root of -20. And that means my first thing I can do is I can put I in front. It actually is going to go in the back at the end, but for now we'll put it in front, so easier to work with. 20 is 4 times 5. 4 is a perfect square. So since that's 2 squared, I'm going to take it out and put it in front. That allows me now to put that in here. 4 plus or minus, or now I'll put 2i root 5 over 2. But to write this the correct way, I have to apply that 2 to both of the terms. So x is equal to 4 over 2 plus or minus 2i root 5 over 2. And then I can cancel these. 4 over 2 is 2, plus or minus. Now the 2's cancel, but the I has to go in the back. Square root of 5i. And those are 2 more answers. And that gives me now my solutions. So that means I have -1 from over here. And now I have these 2. So I have -1. I'm going to put this in black here. So I have -1, and I have 2 plus or minus square root of 5i. And this is 1 real and 2 imaginary solutions. All right. A little slower. The quadratic formula sometimes is very useful. Let's do the next one. This is a good one to try yourself. Stop the video, work on it for a moment, then come back and then I will start again as soon as you unpause it, it'll look as if I'm starting now. All right, welcome back. And so let's figure out from this, what are the sets to numbers to choose from that we can do synthetic division with? So I'm going to do P over Q, factors of and factors of. So for P, it's minus 18. And for Q, it's the 1 that's there. So that means what we have are, since we know it's plus or minus 1 on the bottom, we need all the ones of 18. Negative 18 or positive 18 is going to be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, plus or minus 18. And so I'll put that into a solution set so it looks more formal. I don't really need to do this for this problem because this is just to help me move forward. But of course, I have to be organized in doing it here. So now I'm going to do synthetic division again. All right, so let's do the same kind of thing. This time I'll use the black one here. I'll use 1, easiest one to start with. And let's go ahead and take and do the 1 that's from here, and then the negative 2. So I'll take each one of the coefficients and the constant at the end, and I'll do synthetic division. 1, negative 1, that's 9 minus 1 is 8. That's 8. That adds up to a negative 10, so 1 is no good. So I'll do negative 1. Let's hope this one works. My last one did. In fact, I'll go like this. 1 times negative 1 is negative 1. In fact, this does not look very good here, so I'm going to redraw that. Yeah, that looks better. That gives me a negative 3, positive 3. 9 plus 3 is 12, negative 12. That doesn't do me any good. It has to be a 0. It's not a 0. So let's go to the next one and try it with 2, and then negative 2, and then 3, and negative 3, and we'll just keep on trying. 1, 2 times 1 is 2. Oh, that gives me a 0. 2 times 0 is 0. That's a 9. 9 times 2 is 18. And when I add these, I do indeed get a 0. So here is one of my answers, or one of my solutions. And then, since I started off with a cube, I make this depressed polynomial have an x squared. So it's 1x squared plus 0x plus 9. Well, we don't see the 0x, show the 0x or the 1, so it's just x squared plus 9. Okay, so we have to solve that one. That one is not, it's 2 squares, but it's not a difference. So we can't follow the a squared minus b squared thing. So instead, we'll do this. We'll solve, and we could do the quadratic formula, but then we'd be having the b as a 0. Now that may be possible. That would give us 2 answers. It would work. But instead, we can also just solve it. Okay. X squared plus 9 is equal to 0, making sure we don't miss anything and don't lose a plus or minus. So I'm going to subtract 9. X squared equals negative 9. The square root of x squared equals plus or minus the square root of negative 9. So x is equal to plus or minus. Well, that negative immediately comes out as an I, and the square root of 9 is 3. So what I did here is square root of negative 9. It just does not have to show this every time, but this time I will show that. And so that becomes an I, and that becomes 3. But we usually and should put the I afterwards. So our solution set here is the 2 from over here, and then the plus or minus 3i. And once again, we have 1 real, and 2 imaginary or complex solutions. There. That P and Q thing is really great to use so you have an idea of what numbers to start with. All right, so this is a pretty important concept. It comes from the section after this, but it was appropriate to start it now to make sure you get through these problems.